Something massive is happening in robotics right now, and I don't think most people have fully caught on yet. We're not talking about robots that pull off one cool trick in a lab and then get shelved. We're talking about machines that sprint faster than most athletes, play actual tennis, swim using real, living muscle tissue, and roam deserts without ever needing a charge. This is 2026, and the line between human skill and machine capability just got a whole lot thinner. And the leader of this revolution is not the US. It's not Korea or Singapore or even Japan. No, China's the one leading the pack. Okay, so let's kick it off with the one that got people buzzing for maybe the wrong reasons. AgiBot is a Shanghai-based company founded in 2023 by former Huawei engineers, and in March 2025, they dropped the Lingi X2. This is a compact bipedal humanoid at around 1.31 meters tall, about 35 kilograms, and with 28 degrees of freedom across its joints. Humans have around 200, so yeah, the gap is closing. The X2 walks, runs, dances, rides a bicycle, balances a hoverboat, and can read medication instructions out loud. It has RGB cameras, 3D LiDAR, and a vision language model that lets it respond to the world around it within milliseconds. When one of these had a hiccup at a public event, the internet it lost its mind. But here's the actual story. AgiBot put over 200 robots on a live stage in Shanghai for 1 hour televised gala before Lunar New Year in 2026. They danced, they did martial arts, and walked in a fashion runway. In front of cameras, no safety net, and this is not a tech demo, it's a pressure test in front of millions of people, and they got through it clean. However, it did have a hiccup at a Haidilao restaurant where one X2 robot started throwing stuff all across the room as it started dancing around too close to customers. Staff members assure the public that this wasn't the robot's fault, but that it was brought too close to a table as per request from a customer, creating a chaotic situation for everyone involved. That said, this is just a hiccup, and for a robot that is planned for mass adoption, it's certain that hiccups are gonna happen, especially this early in the whole humanoid robot integration phase. Research firm Omida tracked AgiBot as the single largest humanoid robot shipper in the world in 2025, with 5,168 units delivered. At MWC 2026 in Barcelona, they announced a robot-as-a-service rental program across 17 countries. A glitch here and there? And that's fine. The momentum here is hard to argue with. Now, this one sits outside the humanoid show and gets way less attention than it deserves. Researchers at Cranfield University built Wonder Robot, a fully 3D printed robot that moves on nothing but wind. No battery for locomotion. Zero. Now here's why that matters. Movement eats up roughly 20% of battery life in most robots. WonderBot skips that cost entirely by pairing a Savinus wind turbine with a Janssen linkage mechanism, the same multi-legged walking system Dutch artist Theo Janssen used in his famous Strandbest and beach sculptures. Wind hits the turbine drives the legs, and the robot walks. As long as there's wind, that is. It keeps going. Every single part is 3D printed, meaning that if a leg breaks in a Martian dust storm or somewhere in Antarctica, you print a new one on the site. No resupply flights, no repair crews. It showed up as prototype at the European Space Agency's Astra conference in 2025. Still early days, but the concept is one of the cleanest pieces of engineering thinking I've come across this year. It's not doing backflips, it's just solving a hard problem with a surprisingly simple answer, and that kind of thinking is genuinely rare. Now, things get industrial. In March 2026, UBTECH and Siemens Digital Industry Software signed a strategic partnership in Shenzhen with one goal: produce 10,000 industrial humanoid robots per year by the end of 2026. 10,000 humanoid robots a year. Let that land. The machine in question is the Walker S2, an industrial humanoid that swaps its own battery in under 3 minutes without powering down or needing human help. That's what makes 24/7 factory deployment actually realistic. Their co-agent system gives it autonomous task planning, intent recognition, and self-diagnosis. Since the start of 2025, UBTECH pulled it in over 1.4 billion yuan in Walker series orders from clients including BYD, Foxconn, Geely, and the one that surprised them most, Airbus, which bought Walker S2 units for a manufacturing plant, making aerospace the 5th major industry deploying these machines. Siemens is bringing digital twin technology and PLM software to build a full digital thread form design to factory floor. Right now, a Walker S2 costs around $80,000 per unit, which admittedly is very expensive, but successful sealing could bring that down to $20,000 by 2027, and that's the number that turns this from a niche product into a mass market one. The Walker S2 currently runs at about half the efficiency of a human worker, with target of 80% by 2027. That gap is real, but a robot running 3 shifts a day, 7 days a week with no sick days at half human speed is already a compelling proposition for a lot of factories. Now this is where robotics starts sounding like science fiction. In March 2026, researchers at the National University of Singapore published a paper in Nature Communications about Ostrabot, a biohybrid swimming robot powered by lab-grown living muscle tissue, actual biological muscle inside a robot. The inside that made it work is almost elegant. Young skeletal muscle cells twitch on their own while maturing. Scientists had noticed this for years and treated it as a biological curiosity, and the NUS team treated it as a free workout. They connected 2 muscle tissue rings through a sliding block, so when one contracted, it stretched the other, which then contracted back. No outside stimulation. The muscles just trained each other continuously, like arm wrestling at a cellular level. The result was muscle actuators more than 10 times stronger than conventionally cultural alternatives. Those powered Ostrabot inspired by the swimming style of boxfish, keeping the body rigid and oscillating 2 flexible tails. At 3 Hz stimulation, it hit 467 millimeters per minute, the fastest swimming speed ever recorded for any skeletal muscle-driven biohybrid robot, and more than 3 times faster than the same robot on regular muscle. It also responds to clapping. The team built a sound-triggered start and stop system that actually works. As one researcher put it, the robot is not just alive, it's controllable. Future applications include biodegradable medical tools and environmental sensors that dissolve after the job is done. A robot that cleans up after itself by decomposing is one of the most responsible engineering ideas I've come across in years. Pure momentum. In February 2026, Zhejiang University's Humanoid Robotics Institute unveiled Bolt, built with the Hangzhou startup MirrorMe technology and Kayerda. Named deliberately after Usain Bolt, it stands 175 centimeters tall, weighs 75 kilograms, and matches average adult male proportions. The reveal had MirrorMe founder Wang Hongtao running on a treadmill side by side with the robot. As the speed climbed, Wang hit his limit and stopped, but Bolt didn't. The speedometer hit 10 meters per second, which is 22 miles per hour, making it the fastest full-size humanoid robot ever demonstrated outside a simulation. For context, Usain Bolt's 100-meter world record averages about 10.44 meters per second across the full distance. The robot is already right there at the threshold. In March 2026, Unitree Robotics founded Wang Jingjing and said publicly that the Yabuli China Entrepreneurs Forum that humanoid robots in China could break the 10-second 100-meter barrier by mid-year. What makes it technically impressive beyond the speed is the stability. Bolt uses a high stride cadence rather than long strides, taking more steps per second rather than converting more ground per step. That's what keeps it balanced at extreme velocity. The team built entirely new joint designs and rewrote the power system to get there. Their goal was what they call superspecies machines, robots that match or exceed the physical limits of human biology. And isn't that a bold thing to say out loud? But I think they mean it. Now here's the last one, and honestly this is my favorite thing on the list. In March 2026, researchers from Tsinghua University, Peking University, and Chinese AI firm AgiBot published Latent. Learns athletic humanoid tennis skills from imperfect human motion data. Yes, the acronym is very deliberate and very complicated. Tennis is one of the hardest problems in robotics. A ball can move at 30 meters per second, racket contract lasts a few milliseconds, and the robot has to detect, predict, position, stabilize, and swing in one unbroken loop. No pausing to recalibrate between steps. Now, previous methods needed pristine professional motion capture data. This was expensive and slow, but Latent did the opposite. The team collected just 5 hours of movement fragments from amateur players, forehands, backhands, lateral shuffles, inside a tiny 3x5 meter court. Now, this is imperfect by design, but from that, they built a latent action space and trained an AI policy using reinforcement learning to correct and chain those fragments in real time. The system was deployed on a Unitree G1 humanoid robot, and across 10,000 real-world trials, forehand success hit up to 96% in the simulation, and in live matches against humans, the robot sustained genuine multi-shot rallies using both strokes across different court positions. Not wibbled already, don't get me wrong, but a $13.5 thousand robot trained on 5 hours of amateur footage rallying live with a human is genuinely remarkable. And the biggest point is the principle. Robots learning complex physical skills from messy real-world data rather than perfect curated sets. That applies to warehouses, construction sites, emergency response, you name it. Latent looks like a tennis project, but it's actually something much bigger. Now, looking at all 6 of these together, here's my honest take. We've spent years hearing about the robot revolution like this, and it was always 5 years away. What 2025 and 2026 are showing us is that the waiting is done. This isn't one field inching forward, it's speed, biology, endurance, manufacturing, athletic intelligence, and sustainable design all moving at the same time. China is leading on deployment volume and commercial scale without question, but the science from Singapore and the UK shows the ideas behind all of it are globally distributed. What's converging is everything at once: hardware, AI, manufacturing, and now actual living biology. I find this exciting, but not scary. These machines are going to handle the jobs nobody wants, reach the places nobody can, and compete in the arenas where humans push themselves for fun. That is a pretty good world to be heading into.